I want you to picture something for me. And I want you to really be there for a second.
Okay.
You are sitting at your desk. It's, I don't know, it's 3:00 p.m. on a Tuesday. You have this massive deadline just looming over you.
Oh, I know this feeling.
Right. It could be anything. A quarterly report, a creative brief, maybe a complex block of code you just cannot debug. The pressure is on. You've been staring at that blinking cursor for what feels like an eternity.
10 minutes at least.
10 minutes, easy. And then, without even realizing you're doing it, you stop. You lean back in your chair.
Yeah.
Your eyes drift away from the screen, and they lock onto that blank white wall behind your monitor.
The universal pause. We've all been there.
Exactly. You are doing absolutely nothing. You are, completely zoned out. And if you are anything like me, or like most of the people listening right now, about 30 seconds later, you snap out of it. And what's the very first feeling that hits you?
Guilt. 100%.
It's guilt. You think, come on, focus, stop being lazy. My brain just crashed. You feel like you failed.
It is the modern condition, isn't it? We equate that silence, that kind of mental stillness with system failure. We treat the brain like this machine that only has value when the gears are grinding and the scheme is rising.
And the output is visible on the screen.
Exactly. The output has to be visible.
Right. We think task off means brain off. But here is the thing that absolutely blew my mind while reading through this stack of research for today's deep dive. That moment, when you are staring at the wall and doing nothing, your brain isn't idling. It is not shutting down.
Not even close.
In fact, biologically speaking, it might be working harder and burning way more energy than when you're actually hammering out that email.
It is one of the great counterintuitive paradoxes of neuroscience. When you disengage from the outside world, this massive sprawling network in your brain just lights up like a Christmas tree.
And that is what we are unpacking today. We're doing a deep dive into the default mode network, or the DMN.
The DMN. Some people have called it the dark energy of the brain, the stuff that's running everything in the background.
And I want to be really clear right up front. This isn't just a show about daydreaming. Based on the papers we've got here, and we are talking about a serious stack from Rachel, Buckner, Menon, Svanishvili, Bokola. This network seems to be the neurological seat of us, of the self.
It is. It really is. It's the seat of the self. It's the engine of creativity. It's how we understand other people's intentions. And as we'll see when we get to the end of the stack, it's the battleground for things like depression, anxiety, and even Alzheimer's when it goes haywire.
So let's rewind a bit, because for a long time, scientists didn't even know this network existed. In fact, they thought it was, just noise.
They thought it was a glitch in the data. That's right. This is a classic story of scientific serendipity. If we go back to the seminal paper by Marcus Rachel and his colleagues from 2001, titled simply A Default Mode of Brain Function, they describe how this was discovered almost completely by accident.
This is the origin story. I love that in science, sometimes the biggest discoveries happen when you're looking for something else entirely.
Oh, absolutely. I mean, before this, back in the 90s, researchers using PT scans, positron emission tomography, were mostly interested in what parts of the brain activated when you did a specific task.
The task-on, brain-on model.
Precisely. It's a very logical assumption. If I want to see how your visual cortex works, I show you a flashing checkerboard. If I want to see your motor cortex, I tell you to tap your finger, you provoke the brain, and you see what lights up.
Simple stimulus response.
But to measure that effectively, they always needed a baseline. In science, you always need a control variable, right? You need a control state to compare the active task against. So in between the math problems or the visual puzzles, they would tell the subjects, okay, just rest, don't do anything, close your eyes, just lie there.
The scientific equivalent of take 5.
Exactly that. And for years, I mean, literally for years, researchers treated that resting period as neural silence. They just assumed the brain activity would drop to some baseline hum, a low-energy idle. It was just the background noise against which they measured the real work.
But that's not what they saw.
Not at all. Rachel and his team noticed something peculiar, something that just didn't fit that model. They noticed that when the subjects stopped doing the math and started doing nothing, specific regions of the brain didn't just go back to neutral.
They spiked?
They spiked. And not just a little bit. We are talking about a robust, high-energy network that suddenly came online the moment the external tasks stopped. It was like a hidden engine roaring to life.
So wait, doing the math problem was actually suppressing these areas?
Precisely. That was the huge insight. It wasn't that doing nothing was neutral. It was an active state. They realized there was this specific identifiable network that deactivates when you are engaged in the external world, like solving a puzzle or driving a car, but activates the moment you turn inward. Rachel realized this wasn't noise, this wasn't a mistake, this was a default mode of brain function.
Which is such a vindication for daydreamers everywhere. It's not that I'm not working.
Yeah.
I'm just, entering my default mode.
But here is the real kicker, and this goes back to the energy usage you mentioned at the top. You would assume resting means saving energy, right? That's the logical conclusion. But the DMN is incredibly metabolically expensive.
What does that mean exactly? Metabolically expensive.
It means it consumes a huge amount of the brain's energy budget. We're talking oxygen, glucose. The brain itself is only about 2% of your body weight, but it uses 20% of your energy. And the DMN is a huge part of that 20%. It's a gas guzzler.
And evolution's usually pretty cheap, isn't it? It doesn't like waste.
Evolution is a miser. It does not design expensive biological systems just to let you zone out for no reason. If the brain is burning high-octane fuel while you are staring at a wall, it is doing some kind of heavy lifting. It has to be serving a critical survival function.
Okay, so let's get into the mechanics of this, the actual, the architecture. Because when I hear network, I think of wires connecting point A to point B. But the reading, specifically the updated work by Buckner and DeNicola from 2019, the brain's default network, updated anatomy, physiology, and evolving insights, suggests it's way, way more complicated than just one big blob in the middle of the brain.
Oh, it is definitely not a monolith. That was the early understanding, the 1.0 version, that it was just this one big cohesive system. But as our imaging technology got better, specifically with high-resolution fMRI, which lets us see much finer detail, we started to see that the DMN is actually a complex, layered architecture.
Buckner and DeNicola describe it as comprising multiple interwoven networks.
Interwoven is the key word. Think of a braid or maybe a tapestry made of different colored threads. What's so fascinating is that these networks sit right next to each other. They're juxtaposed in the cortex, but they are functionally distinct.
They have different jobs.
They have very different jobs. Buckner identifies two main parallel subsystems within the greater DMN, which they call DNA and DNB.
DNA and DNB. Not the catchiest names, I'll admit, but let's break them down because the distinction here seems really important for understanding what we're actually doing when we zone out. What's the difference?
Think of them as neighbors who live in the same building but have completely different professions. DNA is heavily coupled with a part of the brain called the parahippocampal cortex.
Which is memory, right? That's the memory hub.
Yes, but it's a specific kind of memory. It's about episodic memory and, crucially, scene construction. This part of the network is involved in reconstructing the past or imagining spatial environments.
Okay, so give me an example. If I close my eyes right now and I try to picture the house I grew up in, I can see the front door, I can mentally walk up the stairs, feel the weirdly sticky banister that is DNA firing.
That is DNA lighting up. It is building a spatial simulation based on scraps of memory. It's the scene builder. It's the set designer for the movie in your head.
Okay, I like that. The scene builder. So what's DNB?
DNB seems to be more related to social inference, theory of mind.
So thinking about what other people are thinking.
Exactly. It's the part of your brain that's replaying a conversation from earlier and trying to decipher what your boss really meant when she said your presentation was interesting.
The overthinking network.
Or the social survival network. So within this do-nothing state, we have one department that's basically filing reports on our past and building virtual movie sets, and another department trying to run social simulations.
That's a great way to put it. And this separation, this specialization, isn't a uniquely human quirk either. The research shows that macaques and marmosets have a homologue of the DMN.
A homologue,
which means what exactly? A biological equivalent?
A biological equivalent, yes.
Yeah.
It suggests an ancient evolutionary origin. This system, or at least a primitive version of it, dates back perhaps 45 million years.
Wow. So monkeys have a default mode network. They zone out.
They do. But, and this is the absolute key from Buckner's review, it has massively, massively expanded in humans. In the primate brain, these association areas are there, but they're smaller, they're more constrained. In humans, they have just exploded in size and complexity. They have physically pushed the other parts of the brain apart to make room for themselves.
Which makes perfect sense, right? I mean, I assume a marmoset isn't lying awake at night worrying about an awkward conversation it had 5 years ago or, planning a retirement party.
Probably not. The expansion of the DMN tracks almost perfectly with the expansion of our social and cognitive complexity. And that expansion leads us to a really interesting insight from a very recent paper, Pacola et al. From 2025. They looked at the architecture of the DMN, specifically where it sits in the hierarchy of the cortex.
The hierarchy, what do you mean by that?
Yes. So if you think of the brain as an information processing factory, the sensory areas, vision, hearing, touch, they're the loading docks. They're at the bottom of the hierarchy. They take in the raw data from the world.
Light hits the retina, sound hits the eardrum.
Immediate, raw input. That's the bottom floor. Pacola and the team found that the DMN is located at the absolute opposite end of that hierarchy. It is the CEO's office on the top floor. It is the top of the cortical mountain. And it is structurally insulated.
Insulated from what? From the factory floor?
From the loading dock, from the immediate sensory input. Pacola calls it an insulated core. The DMN is structurally distant from the parts of the brain that see and hear and feel the present moment.
Why does that matter? I mean, why would we want a part of our brain to be disconnected from reality? That sounds like a bad thing.
Because that insulation is precisely what allows you to think about things that aren't here. Think about it for a second. If your brain was constantly, relentlessly bombarded by the raw data of the room you're in, the hum of the fridge, the light on the desk, the feeling of your socks, you couldn't simulate a beach in Hawaii?
You couldn't remember your childhood home.
Exactly. The signal-to-noise ratio would be way too high. You'd be overwhelmed by the now.
You need to shut the door to the factory floor to hear yourself think.
That's it exactly. That structural distance, that insulation, provides the hardware requirement for imagination and abstract thought. It allows us to process information that is intrinsic, coming from inside our own memory banks, rather than extrinsic, coming from the world.
That is a profound thought. We need to be biologically disconnected from the present moment in order to imagine a new one.
It is the basis of all abstract thought. We detach to create. We have to.
So if the DMN is the CEO in the penthouse suite, insulated from the noise of the factory floor,
Yeah.
what is the CEO actually looking at? If they aren't looking at the outside world, what's on the monitors in that office?
Well, according to the research, specifically a really important paper by Lee et al. From 2014, the CEO is mostly looking at other people.
The social brain.
Yes, this brings us right to the social brain hypothesis, which Lee discusses, referencing the anthropologist Robin Dunbar. The idea is that the reason humans develop such massive brains, and specifically this massive energy-hungry DMN, wasn't to solve math problems or build better tools or even to hunt mammoth.
It wasn't for survival in the elements.
The theory suggests no, not primarily. It was to navigate incredibly complex social systems.
It was to handle the office politics, the gossip.
In a way, yes. To understand who is allied with who is angry, who can be trusted, who is cheating on who remembers that favor you owe them, like, at all. Break down how the DMN processes this social information into 3 specific tiers within a key hub called the medial prefrontal cortex, or MPFC.
Okay, let's unpack these tiers. We've got the bottom, the middle, and the top. This is a really detailed part of the reading, but it feels critical.
It is, but it's crucial for understanding how we build our social world. Let's start at the bottom tier, the ventral MPFC. This area connects deeply with the limbic system, the emotional centers of the brain, like the amygdala. So this tier is all about emotional engagement.
This is the gut feeling tier.
It's about resonance, connecting with how others feel. If I see you in pain and I feel a pang of distress myself, that is the ventral MPFC at work. It's empathy in its rawest, most visceral form. It's feeling with someone.
Okay, so that's the base layer. Then moving up, you have the anterior MPFC, the middle tier.
This one is crucial for something called self-other distinction.
What does that mean exactly?
It means figuring out, is this my feeling or is this your feeling? It's a very sophisticated process. If you see someone crying, you might feel sad. The anterior MPFC helps you realize that the sadness originates from them, not from some sudden tragedy in your own life. It draws the boundary line.
That sounds incredibly important. I mean, otherwise we'd just be emotional sponges, completely overwhelmed all the time.
Exactly. It prevents emotional contagion from becoming total confusion.
Okay.
It maintains the integrity of the self, drawing the line between me and you.
And the top tier, the penthouse.
The dorsal MPFC. This is where theory of mind lives. This is the really high-level cognitive understanding of mental states, beliefs, intents, desires. It's not just feeling sad because they are sad. It's understanding they are sad because they believe they failed the test.
It's the chess player. If I do this, they will think that, which will make them do this other thing.
And It's also, crucially, where we process what is that person thinking about me?
The paranoia center.
Or the reputation management center. It's what allows us to function in a society where our reputation is a form of currency. It is high-level social computation.
There was something in that LEPA paper that I found fascinating about morality. It mentioned that the DMN just lights up during moral judgments.
It does, because moral judgments are almost always social judgments, right? They are about how we treat others, about fairness, about harm. And interestingly, the connectivity changes depending on who we are judging. Lace cites a study by Baumgartner regarding in-groups versus out-groups.
Oh, right. This is the friend versus stranger thing. I found this part a little disturbing, honestly.
It is disturbing, but it explains a lot about human behavior. The study showed that when we judge a friend, an in-group member, the connectivity between these different DMN regions is stronger. We simulate their mind more effectively. We interpret their actions with more nuance, more charity.
We give them the benefit of the doubt because we can almost see their internal world. We can imagine their intentions.
Correct. But when we judge a stranger or an out-group member, someone from a different political party, a different country, or even just a rival sports team, that connectivity drops significantly. We literally use less of ourself to understand them.
That's terrifying. It implies that dehumanization isn't just the social choice. It's a biological switch. We can physically disengage the empathy engine.
It suggests that empathy is a simulation process. And the expert insight here is that the DMN allows us to simulate the minds of others using the very same hardware we use to understand ourselves. If that hardware disconnects, the other person becomes less real to us. They become a 2D object rather than a 3D person with thoughts and feelings.
So the DMN is basically the empathy machine, but it's also the me machine, because you can't simulate someone else if you don't have a coherent self to use as a baseline.
That is the perfect transition. You've hit on the central thesis of Vinod Menon. His 2023 review, 20 Years of the Default Mode Network, really doubles down on this idea of the narrative self.
This was the part of the reading that felt the most philosophical to me. Menon talks about the integrative narrative. What does he mean by that?
Yes. Menon argues that the ultimate function of the DMN, the grand overarching reason it integrates memory and language and social processing, is to create a coherent story of you.
A story. Like an autobiography.
Exactly. Think about it. Your brain is just full of all this disparate data. You have episodic memories, specific events like your 10th birthday party. You have semantic memories, facts like Paris is the capital of France. You have language. You have visceral feelings. The DMN is the loom that weaves all of these threads together into a running autobiography.
It's the editor of the movie of my life. It's creating the plot.
It is the narrator. It's what gives your life a sense of continuity, a past, a present, and a future. And Menon poses a Gedanken experiment, a thought experiment. What would happen if the DMN just stopped functioning completely?
I assume we'd just be unconscious or in a coma.
Not necessarily. You might still be awake. Your eyes could be open. You might still perceive the world. You could see the color red. You could feel that the room is cold. But there would be no subject experiencing it.
There would be no I to say I am cold.
Exactly. There would be no subjective continuity. You would be a camera recording footage with no timestamp and no director. The self is a construct, a story created by this network integrating all these inputs over time. You'd be trapped in an endless present.
So we would lose the timeline, the mental time travel.
We would lose mental time travel. This goes right back to Buckner and DeNicola's point. The DMN is active when we remember the past, but it is equally active when we envision the future.
That's the constructive simulation concept. I thought this was so cool.
It's fundamental. We tend to think of memory like a video file on a hard drive. You double-click it, and it plays back exactly as it was recorded. But the DMN doesn't work like that at all. It's constructive. It takes scraps of data, a smell, a face, a feeling, and it literally reconstructs the scene in real time.
Which explains why our memories change over time. Every time we pull them up, we're re-editing the film a little bit.
Correct. And the DMN uses that exact same constructive ability to simulate the future. It takes those scraps of the past and rearranges them into a new configuration to predict what a job interview might look like next Tuesday.
That's why it burns so much energy.
Yeah.
It's running simulations 24/7. That's like a supercomputer running climate models, but for my social life.
It is constantly running what-if scenarios. This is why you might find yourself completely exhausted after a day of just worrying. You haven't moved a muscle, but your DMN has been running high-fidelity simulations of potential disasters for 8 hours straight. That is incredibly metabolically expensive work.
Okay, so the DMN creates the self, it runs the simulations, it connects us to others. But we also hear a lot about the DMN and creativity. And this is where the research gets a little, it feels paradoxical.
Mm.
Because we are told focusing is good, but also daydreaming is good. How can both be true?
It is a paradox, and the mechanism is far more nuanced than just relax and you'll be creative. We have a fascinating study here by Bartoli et al. From 2023 that really gets into the weeds on this.
This is the one with the stereo EEG, right? With the electrodes inside the brain.
Yes. This is incredibly rare data. Usually we look at fMRI, which tracks blood flow. It's great, but it's slow. It's like taking a long exposure photo of a highway. You see the blur of traffic, but not the individual cars. Bartoli's team worked with patients who already had electrodes implanted deep inside their brains for medical reasons, usually to monitor for epilepsy.
So they could listen to the DMN from the inside in real time.
With millisecond precision. And they had these patients do the alternate uses test.
A classic creativity test. Tell me all the uses you can think of for a brick.
Right. And if you say build a wall or use it as a doorstop, that's considered low creativity. That's just standard memory retrieval. But if you say grind it up to make red pigment for a painting, or use it as a mock coffin for a hamster funeral, that is divergent thinking.
Hamster funeral. I like that. A bit dark, but definitely creative.
And what they found was a specific dance of brainwaves in the DMN during those creative hamster funeral type answers. They saw an increase in gamma power and a decrease in theta power.
Okay, let's unpack that for a second. Gamma and theta, what does that mean?
So gamma waves are very high frequency. They usually signal intense local processing neurons talking to their immediate neighbors very, very quickly. Theta is a much slower rhythm. It's often about long-range communication between different brain regions. So this signature suggests the DMN is working really hard locally to process information and generate these new, unusual associations.
But here's the twist that really caught me off guard. The researchers didn't just listen in, they interfered.
Yes. This is why the paper is so important. It gets at causality. They used the electrodes to deliver a tiny electrical stimulation to the DMN, essentially disrupting its normal firing pattern with a bit of electrical noise. And when they did that, the patients became dramatically less original.
They got boring.
They got boring. They could still list uses, their fluency wasn't affected, they could still say build a house, build a garage, build a chimney, but they stopped saying pigment, they stopped saying hamster funeral. They lost the ability to diverge from the standard, well-worn path.
So the DMN is actually required for originality. It's not just a nice to have.
It seems to be the engine that allows our thoughts to step off the beaten path of semantic memory. It allows us to reach for the remote, unexpected association.
But, and this is a big but, it doesn't work alone. We have another source, a video lecture by Rex Young from the Italian Academy that discusses jazz improvisation. And he adds a whole other layer to this.
I love this study. Jung discusses work by a researcher named Charles Lim at Johns Hopkins. They put professional jazz musicians in an fMRI scanner and had them improvise on a specially designed non-magnetic keyboard.
That sounds incredibly difficult.
It's amazing they could do it. And what they saw was that during true improvisation, the musicians actively downregulated their control networks. They turned off the inner critic, the part of the prefrontal cortex that's usually in charge.
They let the DMN run wild.
Essentially, yes, they enter a state of hypofrontality. Jung links this directly to the incubation phase of creativity. You know that moment when you've been stuck on a problem for hours, you've been banging your head against the wall, and finally you just give up, go for a walk, or hop in the shower, and suddenly, aha, the answer just pops into your head?
The shower principle. The answer appears when you stop looking for it.
That is the DMN taking over. The control network has finally let go, and the DMN is free to drift through all these weird remote associations without the rigid control of the executive brain saying, that's wrong, that's illogical, that won't work. Jung even mentions this structural paradox.
Yeah, this was really weird. He said that in some highly creative people, you actually see a thinner cortex or lower white matter integrity in certain frontal areas, and that this correlates with higher creativity.
It completely defies the usual logic. Usually we think more brain is better, thicker cortex, more connections. But Jung's disinhibition theory suggests that if your brain structure is a little looser, if there is less filtering in the frontal lobes, it might actually allow more of these wild DMN ideas to bubble up to the surface. It's less efficient for strict logic, perhaps, but better for generating unexpected connections.
So to be creative, you need to be a little bit unhinged, structurally speaking.
Or simply less inhibited, less filtered. But, and this brings us to section 5 of our deep dive, You can't just be unhinged. If you were only DMN, you'd be hallucinating. You'd be dreaming while you were awake. To actually be creative, to make something useful or beautiful, you need a switch.
The switchboard.
This is the triple network model, which is discussed extensively in both the Menon Review and the Spanish-Philly paper. We have three major players on the field.
Player 1, the DMN, the default mode network. Internal world, past and future, self-referential thought. The dreamer.
Player 2, the Central Executive Network, CEN. External world, task-focused, logical, goal-directed. This is the part of your brain that writes the email or solves the math problem. The doer.
And player 3, the one in the middle.
Player 3 is the Salience Network, SASN. It's anchored in a part of the brain called the anterior insula. This is the switchboard, the traffic controller, the manager.
So how does the switchboard work? How does it decide who gets control?
The Salience Network is constantly scanning the horizon, both your internal world and the external world. Its job is to decide what is salient, what is important right now. If a fire alarm goes off, the Salience Network detects that as a highly salient external threat.
And it throws a switch.
It immediately suppresses the DMN. It stops you from daydreaming about your vacation, and it activates the Central Executive Network to deal with the fire.
Stop thinking about your childhood, run.
Exactly. But if the room is quiet and the task at hand is boring, the Salience Network might say, okay, nothing important to see here, and it will flip the switch back, allowing the DMN to take over and your mind to wander.
So creativity isn't just the DMN doing its thing, it's the cooperation, the handshake between these networks.
Precisely. Bartoli and Spanish-Philly both note that true world-changing creativity is a dynamic loop. The DMN generates the wild, divergent idea. Let's use the brick as a pigment for a hamster funeral. Then the Salience Network flags that as interesting or novel. Hey, that's new, and it passes the idea over to the Central Executive Network.
And the executive network evaluates it.
The executive network says, okay, is that actually possible? How would we grind the brick? What would we mix it with? Let's make a plan.
The genius isn't in any one network. It's in the flexible, rapid switching between them.
That is the key. You need the shower moment from the DMN to get the idea, but you absolutely need the desk moment from the executive network to execute it. If you can't switch effectively, you're just a dreamer who never ships. Or you're an execution machine with no new ideas.
And this leads us, I think, to the darker side of the DMN. Because what happens when that switch gets stuck? What happens when the whole system breaks?
We're talking about pathology now, and it's a huge area of modern psychiatric research. Depression, anxiety, schizophrenia. The Spanish-Philly paper from 2025 goes into this in incredible detail.
Let's talk about depression first. Because Spanish-Philly describes it almost like a mechanical failure, a stuck switch.
In major depressive disorder, we often see that the DMN is hyperconnected. It is working too hard, it's too loud, and it is trapped in a rigid, inflexible loop. Specifically, Spanish-Philly and others point to a node called the subgenual anterior cingulate cortex, the SGACC.
That's a mouthful.
It is, but you can think of it as the emotional amplifier of the DMN. In depression, this area seems to be locked in high gear. The internal narrative we talked about earlier, that story of you, becomes a broken record of negative self-talk.
Rumination. Why did I say that? I'm such a failure. This is never going to work. Everyone thinks I'm an idiot.
Exactly. And because the DMN is hyperconnected, the patient cannot switch out of it. The Salience Network fails to disengage the DMN and engage the executive network to say, hey, look at the sunlight, look at this task, get out of your head. The person is trapped in the internal simulation of their own misery. The simulation becomes more real than reality itself.
That is heartbreaking. But it also frames depression in a very mechanical, biological way. It's a network failure.
It is. And it's not just depression. Schizophrenia also involves a failure of this system, but in a very different way. In schizophrenia, what seems to fail is the anti-correlation.
Anti-correlation, what's that?
Normally, when the executive network turns on, the DMN turns off. They are anti-correlated. They work like a seesaw.
If one is up, the other must be down.
In schizophrenia, that seesaw breaks. They might both be active at the same time. The strict boundary between them dissolves.
So the internal world and the external world are just overlaying each other, bleeding into one another.
Exactly. And this provides a powerful explanation for symptoms like hallucinations. If your internal simulation generator, the DMN, is running at full volume while you are trying to process external reality, the executive network, you might struggle to distinguish an internal thought from an external voice. You lose the boundary between in here and out there.
And the outline mentions Alzheimer's as well, which that connection was shocking to me.
This is one of the most tragic and compelling connections. The anatomy of the DMN, those core hubs we discussed, the hippocampus, the posterior cingulate cortex, it overlaps almost perfectly with the areas where the toxic protein plaques accumulate in Alzheimer's disease.
Wait, really? The DMN is the primary target.
It seems to be the first system to degrade, and it makes a grim sort of sense if you consider the metabolic cost. We said earlier that the DMN is a high-energy, constantly running system. Some researchers believe this constant metabolic stress makes these specific cells more vulnerable to the accumulation of toxins like amyloid beta over a lifetime. It's almost a use-it-and-lose-it scenario.
And when the DMN degrades?
You lose the self, you lose the autobiographical memory, you lose the ability to simulate the future, you lose the narrative. The person is physically there, but the ghost in the machine, the story of them, is fading.
Wow. Okay, that is incredibly heavy. But the Svanishvili paper doesn't just leave us with the problems. It also talks about a fix, or at least an intervention. Mindfulness-based neurofeedback.
Yes, MBNF. This is fascinating, cutting-edge stuff. It essentially uses our own technology, EEG or fMRI, to help people retrain their own switchboard.
How does that actually work? What does the patient do?
The technique involves showing people their own brain activity in real time. For example, a patient with depression might be in an fMRI scanner looking at a screen with a simple thermometer on it. They are told, your only job is to make the temperature on that thermometer go down.
But how do they make it move? There's no controller.
The thermometer is linked directly to their DMM activity, specifically to that overactive SGACC node we mentioned. To make the bar go down, they have to find a mental strategy that lowers their DMN activity. They have to stop ruminating and focus externally on their breath, on a sound in the room.
So they're playing a video game with their own mind, and they're learning to manually downregulate their DMN.
Exactly. Through trial and error, they learn the subjective feeling of what it's like to voluntarily suppress that broken record loop. And the stats are impressive. Svanishvili cites studies showing a 30–40% reduction in DMN overactivity and a 35% decrease in that SGACC connectivity after training.
That is huge. That's a real biological change.
It is. It reduces rumination, it improves focus, and perhaps surprisingly, it can even enhance creativity.
Because it unsticks the switch. It makes it more flexible.
Correct. By learning to turn the DMN down, you also gain the conscious control to let it up when you need it. You restore the flexibility of the entire system. You aren't silencing the DMN, you are putting the driver back in the driver's seat.
It's like greasing the gears of the salience network.
A perfect analogy.
This has been a lot. We've gone from the discovery of noise in a PET scanner to the very engine of the self, to the source of creativity, and finally to the biological root of some of the most profound mental illnesses.
It is a remarkable journey through the brain's hidden architecture. It really changes how you view your own mind, doesn't it?
It really does. So if we had to synthesize all of this, if we had to tell the listener what the DMN is in just one sentence, what would it be?
I would say the DMN is the ghost in the machine. It is the biological basis for our personality, our memories, our morality, and our unique ability to imagine worlds that don't exist yet. It is what makes us human, rather than just biological robots reacting to stimuli.
And that leads us to the final provocative thought. Something from Menon's 2023 review really stuck with me. It felt almost like science fiction.
The idea about consciousness.
Yeah. Menon suggests that our consciousness, that ineffable feeling of being a person inside a head looking out, might essentially be the DMN broadcasting its internal story to the rest of the brain.
It's a compelling and elegant theory. The DMN integrates everything, past, future, self, others, and then broadcasts the final edited narrative. If that broadcast stops, even if all the sensory systems are still working, the experiencer just disappears.
So here's my challenge to you, the listener. The next time you catch yourself sitting at your desk, staring at that wall, zoning out, missing a bit of a conversation, don't feel guilty.
Do not, please.
Don't think of it as a crash or a failure. Think of it as your DMN coming online. Your brain is running its most complex simulations. It's stitching together your memories. It is building you.
It is the most human work your brain can do.
We want to give a massive shout out to the researchers whose work made this deep dive possible today. Marcus Rachel, Randy Buckner, Vinod Menon, Casey Bacola, Eleonora Bartoli, Georgi Svanishvili, and Rex Young. Their papers are incredible, and honestly, we've only scratched the surface.
Truly pioneering work from all of them.
Thanks for listening. Keep diving deep.
And keep dreaming.